Polk audio subwoofer. Hey everyone, welcome back to the channel. This is Sean from Having Fun Repairs. Got a customer plate amp, most likely Class D amplifier, subwoofer, Polk audio, model number as you see there, PSW10, and claim volume kind of motor boats or makes a popping sound with the audio. And so we're going to inspect this, and actually you can kind of hear it already if I got my RCA cables hooked up. See if I can get a hum on it. Not sure if you can hear that crackling right there. Let me turn the volume pot up and down. Let me get some audio plugged into this and we can actually listen to it. So here we go. I've got a 60 hertz signal at 500 millivolts peak to peak going into it. You should be able to definitely hear the crackling sound now. Of course, if we go down in bass, say 40 hertz, it's a little more predominant. Pretty much in the same area on that volume pot there. Gets all the way up to about 100 hertz. Yeah, popping still on the low end of that pot. Most likely this is just going to be a pot issue, potentiometer issue. But in order to inspect this and know for sure, I mean, because this is an older Polk audio, Class D subwoofer. I believe it's going to be Class D. But you know, it could have some old electrolytics in it as well. But the only way to really know for sure is to get the plate out, give it an inspection, and see what occurs, see what we can find out. See if we can pinpoint and duplicate where the problem's coming from and get that corrected. So that's what I'm going to do. I'm going to take the plate out and we'll have another look-see at it. So yeah, I'm right, Class D amplifier. Now, there are some things I do like about this Polk SW10. I mean, it's not a whole lot of amplification, 100 watts, but in all honesty, it had a decent sound. I also like the fact that around back here, let me bring this in if I can. Okay. Without making my camera freeze up. There we go. You see this big beefy transformer that we have way back here. Alright. Yeah. So no switch mode power supply in this thing. We have a legit power supply. Although not an overly complicated one. As it were. Because it's not, you know, a huge amount of amplification. There's a handful of caps on the board, but I do want to go ahead and test this out. I've got audio going into the right RCA connector. I've got this for test purposes our low pass filter set to 80. So to attenuate as much noise possible above 80 hertz to 160. Volume at minimum. Actually, I have my SIGGEN set for 160 hertz. We're going to turn up the volume. Now my probes are set by 10 by, and my O-scope is set to 10 by on channel 1 as well. And so we see that there, 6.8 volts peak to peak, 160 hertz. Now let me see this low pass filter works. So I would expect more amplification as we get up to 160 if this low pass filter was actually working, because we shouldn't be filtering out as much as of that high frequency. Now, just in case for those of you who ask, well, you got the audio going into the red lead here, typically representative of right channel. What about your white RCA lead? Because sometimes the low pass filter only goes to one side and not the other. Well, yeah, let's test that. So now I'm switching over to my white lead. You can see it right here. Let me put my clips on ground. There we go. And let's put positive clip right there on the center channel, just like that. There we go. It's on the white. And I'm gonna set this over here. Let's again turn up the volume. There we go. 6.8 volts peak to peak, low pass filter. Let's turn it clockwise. And yeah, no changes there. Okay. Why don't I drop this down to 140? So our amplitude is definitely going up. So I'm going to scale it down here a bit. And we'll go down to 100. Okay, there we go. And again, I'm sitting on 80, 100 hertz, as you can see there on the O-scope. What happens is I change this past 100. Nothing. Still 5 volts peak to peak. Okay. And for hoops and giggles, switch back over to the red RCA cable. There we go. And yeah, still there. No change as I move this around. None whatsoever. That's me touching the volume. Okay. So let me bump this down to, let's get this to 80. 60. Ooh. Go down to 40 and change my horizontal. There we go. And yeah, I'm in 10 by probe here in 10 by. And how much amplification do we get? Ooh, probably bump that up significantly. Yeah. All right, there we go. From 0.5 volts input to our output. Let's see, before clipping occurs. And we got clipping right about there. It's roughly 74, 75 volts peak to peak. And then clipping occurs afterwards and keeps us right there around 75. Okay. Of course, you don't want to operate in that clipping range. So we'll call it we'll call it 0.5 volts peak to peak and 75 volts outwards, and we can do all the maths and stuff from there. But we have that issue, that popping issue, and our low pass filter, as we're seeing, it's no worky. It's no worky either. So you might be saying, well, is this going to show me a low pass filter issue? Here, I'll show you how we can actually see that. I'm going to turn off my SIGGEN, okay? Turn down my volume. I'm going to take and put my probe into 1x, okay? Disconnect my SIGGEN from this RCA cable. All right, just like so. Okay, let me put the oscilloscope into 1x, just like that. Okay, yeah, there we go. Yeah, I like that. All the hertz right there. Okay. Yeah, I mean, you can, even when I take my finger off, you see those dips and pops that kind of happen in that right area of the oscilloscope. That one just occurred left. It's in random spots when I move it back and forth. That's really what I'm looking at there, is that distortion. It's on that line. I'm more concerned with that jaggedness there and the occasional pop you see when we turn that volume knob, especially when I do it quickly. Oh, you saw two of them right there. So that's indicative of a bad volume pop. But we have other issues as well. We have a low pass filter that doesn't work too. So multiple things that need to get resolved that we will resolve for the customer, since they are a paying customer. So let me get this broken down a bit more. All right, so I've got this taken apart a bit more. And man, what a pain in the butt it is with all this elastic that's on everything. Okay, I actually broke the leads off the LED to take the LED connector off, so I'll have to go back and either replace that or swap that out. Okay, so we can take a look at now these potentiometers here. Let's see if I can position this. So we have an A50K dual taper pot sitting here, and a B20K dual taper linear pot sitting here. And underneath, it appears as though only one taper is used on the A50K, the back side, because the front 3 pins are all on the same plane, all on the same tray, so they're essentially shorted out. And for our B20K, it appears the back and the front taper is being used. Okay. So what this means is I can test out the resistance of these guys. Let me put it this way to kind of give an example of what we're looking for. And I'll take my multimeter. It can sit there. And this is somewhat focused right here. All right, so this should go over the left and right pins. And there you go. You got 49K sitting right there. Okay. And as I turn the potentiometer, you can see we go down to 0. So again, the A is for logarithmic, if you can say that fast enough. But what it means is the resistance is not linear. It's not like, you know, if you were to put it onto a graph, it's not increasing linearly as you increase the amount of current going through. It's not linear. What happens on a logarithmic potentiometer is it kind of has a bell curve to it where it goes up maybe slower than quicker and then tapers off towards the end. Now, what that means is you get a lot more amplification towards, say, like the center of the pot, most likely, and then less at each endpoint as far as decrease in amplification. But we need to check this B20K as well. Remember that there's popping sounds in the A50. Here goes our B20. And we're measuring 18K. All right, where is that at? Am I on this? No, I'm not on. I've fallen off again. There we go. 18K. And there's no action. There, just come up this way. Yeah, I can turn this pot all day and I'm not seeing a change, and that's not good. Come off the center here on that. There goes 18. Yeah, no change whatsoever. I mean, it's just, guys, got to be blown out. That's where I slipped off, I think. Let me try to get on there more. Yeah. Yeah, nothing. So I can take these out and take them apart, but really they just need to be replaced. None of the caps look to be in very bad order. I hate this. What they do with this stuff. You know, this elastic, it does get conductive over time, and they use this potting material, whatever this elastic or potting material is, to kind of deter you from working on this. And yeah, I mean, it does kind of deter you, but it makes it harder to repair as well because, well, essentially it's glued everything, your pieces and parts together. It's annoying. I don't like stuff when I see stuff like this, but this is kind of what you expect given the brand of the product you're working on and everything. So I need to desolder these. Let's see again. VR2 is what that pot's A50K is listed as. Of course, I can't see on the board for the B20K. But I need to desolder these, and I'm going to get them removed from the board. And what we're going to do is we're going to end up just replacing both of them. And that should solve that popping issue. When I get it all put back together, we'll replace the heat sink compound. So this is basically the main amplifier sitting right here. What is that? I see TDA something or another. I've seen these many times over, and especially in like 2-channel amplifiers or smaller amplifiers. TDA 7294. Yeah, that's gonna be the main, or the bulk amplifications coming at for our audio. So that's gonna get heatsink swapped out there, cleaned up here, and it's gotten kind of old, and it's kind of hard for you to see. I mean, it is still a bit wet, but a lot of it has dried out. This goes to that side. You can't lose that that insulator sitting right there, that piece of plastic. It keeps the metal from shorting out to the chassis, because you don't want that shorting out to this chassis. You have to insulate it, provide insulation for it. But yeah, I'll get all this cleaned up. I'll get some of these taper pots, dual taper pots on order. I mean, I can just go ahead and replace the A50K with a B50K. It's going to be more linear. I mean, it's going to function as it should. A 50K pot's a 50K pot. Whether if the bulk resistance decreases mid-range, or if it's just linear all the way through. It really just depends on what I can find. But A50K dual taper pots are not as common to find, say, on like Amazon or something like that, unless I get them from Mauser. Might be able to find some there. But anyways, yeah, that's rambling. Let me get some of these on order, and we'll come back and replace them and put this back together, and see how it functions from there. I ended up getting a set of different dual taper potentiometers off of Amazon. They're pots. They're not going to be... what's the word I'm looking for? It's not going to be detrimental where I procure these from for what we need them for. Now, I will say that the A50K is getting replaced with a B50K, so it's going to be linear instead of logarithmic. And all that is like when you turn the volume up, instead of it going like ramping up something that's more natural that people like to hear, it's going to be a linear volume increase. So there will be a slight difference there, but it won't be anything that's what am I thinking? It won't be anything that's going to be detrimental. Okay, so since I've gotten these, I need to get these old ones out and new ones soldered in. So that's what I'm going to do. Okay, it's all back together. The hardest part was getting that mica insulator or whatever, plastic, maybe plastic, behind the amplifier. Well, essentially that IC that's amplifying our audio. Getting that situated good enough, but everything else has gone together pretty well. I will have to touch up with some hot melt glue around this LED light, but I've got it all back together good enough to test, so that's what we're going to do. The first thing I'm going to do is power it on, and hopefully I've done everything right and nothing catches fire. So let me get the power turned on. Okay, I've got 120 at the outlet. I've got live power. I'm taking my rings off. See a red LED, that's good. Got a red LED right there. It is on. Nothing is blown up. Okay. Let me get some audio plugged into this. Let's see. The first thing I'm going to do is take a look at that oscope with the amplitude all the way, down pretty good. We're just going to do the volume pot, see if we get any of those dips like we got before. No, that is looking pretty steady. Now, if I was to put my finger on there, you get that AC hum. All right, that's pretty natural. As a matter of fact, that's what happens when you put your finger on your RCA plugs when they're hooked into your surround sound. That hum you get, it's just you're causing the 120 volt 60 hertz signal from your outlet to get picked up on those leads. But yeah, when I'm doing this volume up and down, I'm not seeing any of those sharp dips that we saw earlier, indicating to me that anything was popping. So I think it's safe for me to turn. Let's see. Go 10 volts per division. I think it's going to be safe for me to feed in some audio. So we'll start with a 100 hertz. Oh, no. I'll start with a 100 hertz signal at an amplitude of 0.5 volts peak to peak. Okay. I don't have it turned on just yet, but I'm going to plug it into our white. Because I think it's the left channel that goes through the low pass filter, the LFE. I could be wrong, but typically it's the left channel, I believe. Don't quote me on that. All right, turning the output on. And there we go. We got a 100 hertz signal. Of course, I got my low pass filter all the way down here on 80. What happens is I get it up past 100. Oh, we've got a response now. This is good. Okay. So yes, that's what I should see on an LFE. Okay. Excuse me. So right here is around 100. Obviously, as I increase above 100, that amplitude of my 100 hertz signal is going to increase because I'm allowing more audio through. Now, if I was to take this up to, say, 160 hertz, it should drop in amplitude. Let me bring this volume control up a bit. So let's do 160 hertz. And you see how it dropped in amplitude with this pointed north towards 100. But if I get up to 160, the amplitude should increase again. Okay. So yeah, the LFE is now working. Let's do 40 hertz. Ooh, yeah, clipping. We'll take this down. 40 is below 80. We can see that some of that 40 hertz signal. Yeah, there's not a huge change as I change the low pass filter or the LFE, but there is a little bit of change. So around a little above 100. We're talking about what, 31 volts, 39. Yeah, it's quite a bit of amplification, but we're just filtering out that 40 hertz signal a little bit less. Of course, it's not being completely filtered out because the lowest filter setting, according to the dial, is 80. So cool. I'm liking this. And what do we get clipping at? Is my probe in 1 by? It is. Let me take it to 10 by. Change the setting here. Okay. All right, that's on 10 by now too. All right, so 0.5 volts peak to peak in, and we're getting 60, 62, 69, 70. You can see it's flattening out there around 70. Let me change my vertical scale. Bring it down just a bit more. Okay. So 75. Yeah, we're starting to clip around 73, 74 volts. And hard clipping above that, keeping us right at around 76. So again, we're never going to want to operate the volume control max. If you're feeding a 40 hertz signal at 0.5 volts peak to peak, now there's no telling what low level audio is coming out of your subwoofer on your AV receiver unless you've hooked a multimeter up to it and measured it in AC. I imagine it'd be somewhere around 0.5 volts RMS. Of course, this is 0.5 volts peak to peak, so slightly different as far as how that voltage is calculated. Slight difference between peak to peak voltage. Peak to peak is an absolute value. RMS, which you would make with a multimeter, that's root mean squared. It's a different type of calculation. Get your AC measurement, but we can still determine prior to this clipping, say 0.5 to, what does that say right there? 70. Roughly 74, how much gain we have before we get it into clipping. That'd be something I can throw up on the old interwebs there. But that's cool. So really all I need to do now is just get this back into the, everything back into the subwoofer. And well, I kind of want to take this. Yeah, here goes the B20. I kind of want to take this apart to see where it failed. I tested it out when I was removing things, but the tapers obviously, I don't know if the traces or what's ate up in it. Yeah, let me get this out of the way, back into its case. We'll take this this potentiometer apart, see if we can determine what failed in it. As I stated, curiosity does often get the better of me. And I've seen inside of these potentiometers before. I've had to take several apart in the past just to inspect and look at them previously. So over here is our A50K. I've kind of quasi taking it apart. This one's our B20K. All right. Now I'll just kind of go over the composition of how these things are made. So where's my focus at? Okay, you see those prongs there that rake? Looks like a fork or whatever. So that goes along the outside. You see where our carbon track is at right there. But if you notice, and behind it, there's two prongs right behind the fork, and they're situated over an inside trace. Now, as I turn, okay, you can see that the inside ones, they never lift, and neither does the outside fork as we're going around these traces. Okay, either the carbon trace or usually that center one is, you know, copper or some kind of conductive metal. Oftentimes it can also be carbon, but you generally speaking don't want that center one to be carbon. All right, and so now we've gone fully over. Well, you can see we have a start, we have an end, start, end, and the center one, which is our taper, that's what those bottom two prongs are. The inside ones are supposed to essentially what they're tapping off with. So what happens is, as that fork is going over this carbon trace, well, resistance increases, okay, from the carbon trace through that fork or that rake, and then that is electrically conductive because it's all one piece. So current can has a way through to those back two prongs, hitting that center trace, and then coming off of our tap right here. Anyways, so that's kind of how it works. Because this is this one's dual gained, or however you call it. You know, you can see the back side of it right here, and how that, you know, the composition of the rake and then these two prongs and how they're all, you know, connected together. Of course, this being down on the inside now, I was playing with a multimeter a few minutes ago, so ignore those hard kind of scratches. Now, I wasn't really scratching, but the more glossy ones, that the glossy area comes from the center prongs and then that rake continuously going across the same surfaces. So what happens essentially is these carbon tracks have a tendency to wear down, so you barely touch it and you're gonna scrape it. Like, I'm not putting a lot of pressure on this at all, but when they get glossy like this, they lose their conductivity. Okay, and so there's really no way to fix a carbon trace. Yeah, you could put down, you know, like some carbon granules, but unless they stay impacted on the surface and don't move around, you're just going to have a failure again. Of course, this inner trace, like I said, sometimes it could be carbon, sometimes it's fully metal. I believe this one's fully metal. But as they get polished too, and those center two prongs rub against it, when it gets super glossy, it's basically eating away or etching away or scraping away the top layer of metal and stuff. So after a while, you lose continuity between the outside rake or fork and then the inside. Ooh, forgot my screwdriver was magnetic. This inside via, okay. And like I said, as the rake or fork comes across here, and the amount of resistance increases from this point to this point, okay. Whereas on the other side, from that point to this point, the amount of resistance will begin to decrease. However, from these 2 points, it always remains the same. So you'll always see this as a, you know, a 50K pot from the outside too. Okay, so that's the 50K pot. And over here is our 20K dual taper pot. So again, the inside, as you see right there, and like I said, ignore the slight scratching you see in there. That's from my multimeter leads. You can see this one is very much worn out and glossy on the inside. Of course, I think this was the back one. The front one, I believe, was the one that was not all grounded out. I can't remember. I'll have to pull the amplifier board back out or go back and look at some videos, but they're making, there might be a small air gap with those back too, so that could be one of the reasons. But like I said, when it rubs and removes enough material, eventually you're just going to have a gap. And so you can take either that rake here or those prongs and bend them down. That might give you some serviceability for a while. But again, once you start wearing out that carbon, you know, you're best just to replace it. These things are not super expensive. Okay. And when I'm thinking about my customers and working on stuff like this, I'm thinking longevity. I'm not just here to patch something and make it work again. Okay. I'm concerned with, you know, the longevity, the customer being happy, not having to come back for something to repeat. So again, I'm not going to, you know, just try to fix this and give it back to them because I want to make a cheap repair. What I want to do is I want to make a lasting repair. All right, so you can see as I start to go around with my multimeter, how our resistance increases. This is around the carbon trace. Of course, I'm not following the same track per se as the rake on the outside. You can see essentially it's a 20K pot. So I said 20K around those leads. But our taper here, the center tap, okay, when I start to go around it, you see where it jumps up as I'm going around. Some spots seem to be good. Other spots, not so much. And you know, you only have those 2 prongs and they just hit the same spot. And here I am going back and forth in the same area. And, you know, I could have 0.1, move over like a millimeter, and I'm OL touching the same center trace. So you see where we have, it really depends on where these center pieces right here are hitting on that, excuse me, these right here. Right there, where it really depends on where they're hitting on that center trace and if you got continuity there or not. So that's the main failure point. Not really, you know, the carbon outside is going to wear down after some time, and that will be a failure point. But you can just see just repeat use and how it, you know, erodes at that center trace, starts getting it super glossy. And this has been my experience. This has always been like the primary failure point. Now cleaning them up can restore conductivity again. Okay, say especially if they're tarnished. But again, I mean, they're going to lose that. Like I said, it's all just replace them. They're not super expensive, and you know, you're doing this for customers. You're not getting a repeat customer over the same thing, at least not immediately. Eventually, these will wear out again, but You know, this is an old 100-watt subwoofer, so it's been years since this was bought. So you take that for what it's worth. All right, so here we go. We'll do a test. Now, I will say at what, 0.5 volts peak to peak input, and then we did 40 hertz signal right before clipping. We're about 74 volts peak to peak. That came out to roughly what, 43.405 dB a gain, with max amplification being around 109 watts or 100 watt Class D subwoofer. So it's not too bad, but again, you know, it's a 100 watt subwoofer. It's also a Class D subwoofer, and y'all know pretty much my feelings about Class D products. Yeah, I'll fix them, but some I definitely won't like that clips. Anyways, so let's see. A couple things I want to cover with you before we test it, and I did this with the customer's permission. See where the volume pot has a little Sharpie dot. So with the LFE, or low pass filter, at maximum, okay, I increase this until we start clipping at 40 hertz, okay. And so I traditionally do this when you get higher frequency, you have less clipping than you do at lower frequencies on these subwoofers. So what I do is I set it to a lower frequency of what you can expect to get from a movie or something and want to reproduce at the speaker. And I think 30 and 20 hertz is probably pushing it, but 40 is there in the lower end of the range and perfectly acceptable in my opinion. But as soon as where clipping occurs, that's where I throw down a mark, and then I recommend to my customer to not increase volume beyond that point, okay? Now, as far as the low pass filter is concerned, you know, you see that you have 80 on one side and 160 on the other. Well, you know, a low pass filter is going to pass anything, well, essentially, my name, anything at that frequency and below, and then anything above it will start to be attenuated. It's not a full attenuation. So right there at 80 hertz, if I was to pump in 120 hertz, I would see it, but it'd be significantly attenuated. Well, most customers like to have it somewhere close to, say, 80 or 90 hertz to get those amplitudes at maximum, and the other ones any higher than 80 or 90 hertz to start attenuating. So what I do is I pump in a 90 hertz signal, okay? And then what I do, since that's at 80, is I start increasing it until I see reaction, meaning the amplitude of that 90 hertz signal starts to go up, okay? And there goes the lower end. And then I start, and this will stay exactly where it's at right there. Then I start to increase until I get the max amplitude of that 90 hertz signal, and it stops increasing from that point, which would be like right there. And of course, anything over, you know, if I did that there, you wouldn't see anything else really increase with an 80 hertz signal. Now, all these other signals that are present, frequencies, say 100, 120, 110, 160, those are going to naturally increase in amplitude as well as I go up, but they'll still be the attenuated to a certain point until I've surpassed them on the dial, okay? But at least at this point right here, my 90 hertz signal is at its maximum amplitude before it stops increasing, and frequencies at like 100, 110, 120, yeah, they're not going to be as high in amplitude as the 90. They'll still be somewhat attenuated, but and then here on the lower end is where I'll first start to increase on amplitude. So what I do is I make these two marks here, and I tell the customer, if your preference is around a 90 hertz signal, right, suggest some 80, 90. If you wanted to do 100, right, I would do the same thing. Then I make the marks where it will first start to increase, and then where it last stops increasing at that frequency. Now, you have to actually, at this point, Now they're marked. You make the adjustment between, the customer will be making the adjustment between these two ranges to something that is more comfortable for them to hear. Because like I said, if you go to the higher side where 90 hertz is at maximum amplitude, well, you got to also consider your 100, your 110, your 120 is also going to be at a higher amplitude as well. Whereas right here, anything above 90 is going to be at a lower amplitude, but my 90 has just barely started to increase. So the difference is substantial. So this would be around, I think when I was measuring it, 90 hertz, I think I was at 40 something volts over on this side and 20 something volts peak to peak over on this side. But of course, I probably over explained to the point of confusion. But anyways, it's something I do so that way a customer knows wherein they should probably keep their low pass filter for their best, listening based upon what frequency they want to be at maximum and what frequencies they want to be at minimum. And then they adjust it to their liking between those 2 points. Anyways, so yeah, all that's together, and we'll turn on the SIGGEN. Now, I didn't have to mark it with a Sharpie. I could have just wrote it down, but I know this customer very well, and they're perfectly okay with what I did. But let's turn on my SIGGEN. And yeah, I don't have this set to auto on, so I've got to flip on the power in the back. All right, so we're at 40 hertz. You can hear it. But notice this as well as I mess with the volume. No popping anymore. Now, if I was to take that 40 hertz, put it at that marking, and adjust my low pass filter, you can hear slight alterations in that 40 hertz signal. But once we get up to, say, 90, because that's what I gave that tunable range to. All right, we're at 90 on the low end. Here will be 90 on the higher end. That will probably be too high. Vibrating certain things, but you can tell that there's an increase in amplitude of that 90 hertz signal through that range, right? But just keep in mind, as I increase the amplitude of that 90 hertz signal through this range that I gave to the customer, I'm also increasing the amplitude of the frequencies that are higher than the 90 hertz as well. Okay. So, but those would be my recommended settings, and he can set them up from there. But like I said, no more popping, and we have a working LFE now. The customer didn't even know that his LFE was not working, or maybe he did. But that wasn't something he mentioned to me. He just mentioned volume something bad, makes popping sound. I put his initials there. So that's going to do it for this repair. Pretty simple thing. Stuff you could check as well if you're inclined to take apart a Class D subwoofer and you've got popping. Traditionally, a lot of times it could be capacitors, but this one a little more modest. It was bad potentiometers. So yeah, I was actually pretty excited to do this repair. But yeah, so that's going to do it. If you've enjoyed this video, let me know by giving this video a thumbs up, or leave some comments in the comment section. I'll try to respond to as many people as possible. If you're looking for a repair, go no further than looking in the description of every video. It'll take you to my Google site. People, stop calling my contact phone number directly. Email me. I don't answer the phone number unless I've gotten an email first. Unless I know who I'm talking to, because I just get too many people calling me asking me to repair stuff for free. I'm not ever going to do that. My time is valuable, okay? And that means that I'm going to charge for repairs. I don't know why people think that
their product because it gets featured on a YouTube video by your permission that I should repair for free. I don't think so. You know, even though the parts were pretty cheap on this and a lot of other things, parts can get super expensive, and I'm taking a lot of time. So no, I do not make enough off of YouTube for YouTube to be a full-time job. As a matter of fact, I even do these repairs part-time outside of my full-time job. So, but anyways, if you're looking for a repair, go no further in the description. It'll take you to my Google site. Download the request for repair form, fill it out, email it to me, and we'll start from there. That all being said, please consider subscribing if you're new to this channel. Appreciate your time. Thank you for watching. Take care, and goodbye.
Bark.